All right, example 2 and 3. We're going to find the area of the surface correct to 4 decimal places by expressing the area in terms of a single integral and using your calculator to estimate the integral. So there's probably a way to do a double integral in the graphing calculator. Especially, you could download a program to install into your graphing calculator to find that. But say you don't know how to do that, and you know how to take the integral of your, you know how to take the integral of a single. You know how to take the single integral of using your graphing calculator. So that's what we're going to do. We're going to break what we have down into a part where we're going to be able to do one but not really the other, and the integration. And so we're going to break it down to one single integral, and then we're just going to use our calculator to find the rest. All right, so let's go ahead and look at this. The part of the surface, so we're given our surface is cosine x squared plus y squared that lies inside the cylinder, x squared plus y squared equals 1. So let's go ahead and look at what that looks like. And so again, I'm just going to go ahead and graph this, and I'm going to cheat on this one. I'm just going to go ahead and draw my circle. Alright, and that looks pretty good, but for center. And so that's going to be, whoa, this thing is not calibrated perfectly. And so again, that's 1, that's 1, that's negative 1, that's negative 1. And so where it says inside the cylinder, so we're going to be inside that cylinder. I wonder what happens if I just hold it down. Will it just give me a nice circle? It won't do anything. All right. So it did do something. It gave me an arrow. I don't want an arrow. I want a circle. But you know what? Who cares? Let's just go ahead and do that. That was a lot faster. All right. So now it says we want to find the area of the surface correct to 4 decimal places. And so let's go ahead and find our partial derivatives. So we know our function z. So our partial derivatives of this would be, so taking the derivative of that, so the derivative of the inside is going to be 2x with respect to x. The derivative of cosine is going to be negative sine, so negative 2x sine of x squared plus y squared. So there's the partial with respect to x. The partial with respect to y is going to be basically the same thing, negative 2y sine of x squared plus y squared. All right. Now, let's look and see what we got. We got to put that in. So we're going to start with, our region, so A of S. So we're finding the surface area, and we're going to take the double integral. We're just going to say of our region D. Again, that's the domain. And I'm going to go ahead and substitute this in. So I'm going to go ahead and square my partial of x. So let's go ahead and square that just to save some room because I don't have a lot of room. So that's just going to be 4x squared sine squared x squared plus y squared, plus do the same thing with sine. So it's going to be 4y squared sine squared x squared plus y squared. And then I also have plus 1 dA. All right. I can clean that up to be the square root of, and I can pull out an x squared, y squared, and a 4. So we can pull out 4x squared plus y squared. And we will have sine squared x squared plus y squared. All right, and then we still have that plus 1 over on the right. Yeah. Well, I have a circle for my region over here, so let's go ahead and just change the polar coordinates. All right. So changing the polar, all right, so we're going to have, so I'll just denote right there. We're going to polar. Our theta is going to go from 0 to 2 pi. Our radius is from 0 to 1. And then I can rewrite a lot of this. It's just going to be the square root of 4. I can't rewrite that. I can actually take the square root of that, pull it out, make it. Well, no, I can't. I'm sorry. I can't do that. Why? Because it's plus 1 right there. All right. That x squared plus y squared is just going to turn into r squared. And then I have another sine squared of r squared plus 1. And then I'll say r dr d theta. Don't forget about that little r there. All right. And then I can break this up to be the integral from 0 to 2 pi d theta times the integral from 0 to 1 square root of 4 r squared sine squared r squared plus 1. I'll put the r out in front, dr d theta. Now, this integral stinks, all right? Let's let the calculator take care of that, and I'm going to go ahead and do this one, all right? Because that's very easy. The integration would just be theta, plug in that, so I'm going to get 2 pi times the integration from 0 to 1 r square root of 4r squared sine squared r squared plus 1 dr. And now I'm just going to type that into the calculator. When I do that, I'm going to get 4.1073. And that's it. There's the solution. I should go ahead and highlight that. All right, did I highlight the one above? Yes, I did. All right, that's it. I'll stop it right there. I'm sorry for keep moving the screen on you, but that's it. There it is. Again, you could pause it at any time, so when I'm not just changing or flipping the screen on you, you can go straight to it. All right, let's go ahead and do the last one. Example 3. Find the area of the surface, the part of the sphere x squared plus y squared plus z squared equals 4 that lies above the plane z equals 1. All right, so let's first look at, the intersection between the two, because, that's what I'm going to be above. And so I can just go ahead and plug that in for 1. And so the intersection is going to be x squared plus y squared plus 1 equals 4, or x squared plus y squared equals 3. And so it's not this. So let me just give you a picture of what this is actually doing. All right. Say, hey, we have, our three-dimensional percent. And here it's like we have a sphere of radius 2. All right. And so here, there's a sphere of radius 2. Kind of draw it this way too. That's behind it. And then we have we have a plane that's cutting that in half. Now, let me do that a little bit lower. No, I don't want to do that. All right, that's cutting that. Sphere in half, and so kind of like what I have is, I have this top portion of this, we had the whole sphere, and we're just cutting it right there, and we're trying to find the surface area above. So we're trying to find the surface area there. So when I set these equal to each other, and when I'm drawing the actual region above, I'm actually drawing this at z equals 1. All right, and so would be radical 3, negative radical 3, negative radical 3. And again, this is basically up at z. So like if this was, that's 1. So this plane right there is basically described by that. All right, so that's really not on the xy plane. It's on the plane z equals 1, but in terms of x and y. All right, so we're doing it. So we're doing everything above this region right here. Which is good. Polar. We like doing polar. And so we have almost everything we need. The only other thing that we need is we need to take care of our equation. So we have our region D, and then we need our Z. And so our Z is going to be defined by solving our spherical equation for Z. All right? And so I'm just going to get the square root of 4 minus x squared minus y squared. All right, and the reason it's this, usually when you do it, you do plus or minus, but we're only doing the part above 1. So this is the positive part of z. Anything below the xy plane is going to be negative. And since we're only doing the positive, so above 1, it's going to be z equals, just the square root of 4 minus x squared y squared. So let's go ahead and take some partial derivatives. So we take the first partial derivative. So the partial derivative, I'm going to go ahead and erase this to get some room. All right, so the first partial derivative of x is going to be, looks like the derivative of the inside would be negative 2x. We have 1/2 on the outside, so we negative x. 4 minus x squared minus y squared to the negative 1/2. And then if I do the partial y, very similar. All right, that'll be negative 2y, but again, I'll have a 1/2. So that's going to take care of that. So negative y 4 minus x squared minus y squared. And again, I want you to get it right. And so you take your time. If you can't do all this, take your time and write it out as you're doing the derivative here. I'm just doing part of it in my head, not a lot. And so hopefully, if you're working this, you see why I'm able to get the partial derivatives that I'm able to get. All right, and so our surface area is going to be the integral for our region D, and we're going to be from... so we're just going to go ahead and I'm going to square our partial of f. So it's going to be x squared times it looks like we have 4 minus x squared minus y squared to the negative 1/2 squared. So that's going to be to the negative 1. So 4 minus x squared minus y squared. So all I did was to square that. Plus, now I'm going to square the partial of y. And I'm going to get y squared. And then 4 minus x squared minus y squared. And then again, that's going to, these are both to the negative 1. And then plus 1 dA. Alright, I'm going to rewrite this to be something that's going to be better to work with. So I'm going to pull out an x squared plus y squared. And then I have 4 minus x squared minus y squared to the negative 1. You know what? I'm going to rewrite that too. So I'm just going to change that to minus x squared plus y squared to the negative 1 plus 1 dA. Alright, now I have a circle, so let's do polar. So I'm going to change everything to polar coordinates. So I'm going to go from theta first, and that's going to be a full circle, so 0 to 2 pi. And then my radius is 0 to square root of 3, radical 3 is how far the radius extends. And then I'm going to have the square root, x squared plus y squared is just r squared. This is going to give me, you know what, let's go ahead and rewrite this to be, whoa, went too far, the square root That's going to be r squared divided by 4 minus r squared, because that negative 1 puts it in the denominator, plus 1 dA. Whoa, not dA. Let's go ahead and change it. R dr d theta, r dr d theta. And then I'm going to go ahead and pull out the 0, 2 pi d theta. Now, this right here, and again, I did this kind of like in the homework too. I'm going to go ahead and change that to be, if I have r squared over 4 minus r squared, I'll put this like in a little box, you know, that's over to the side. And I'm going to add 1. I can just, if I want to get a common denominator, I can just add that. So 4 minus r squared over 4 minus r squared. If I do that, the r squareds are going to go away on the top, and I'm left with 4 over 4 minus r squared. And so then on the inside here, adding those up, I'm going to get 0 radical 3 square root of just 4 over 4 minus r squared, r dr d theta. And I can actually do the square root of 4 on the top, so I'm going to go ahead and do that. And so I'm going to get, just want to see where I want to put the room. So this right here, when I integrate, it's just going to give me 2 pi times the integration from 0 radical 3 to r over the square root of 4 minus r squared. I'm going to write that 4 minus r squared dr. I don't know why I wrote an extra d theta right there. All right, so again, square root of 4 is just 2. That's how I got the 2. And then I put the r that was on the outside, I put it in the numerator. So that's how I got that 2r there. All right, and again, I can integrate this. And so I'm going to have 2 pi times, all right, that's really, you know, square root of 4 minus r squared. All right, I can do u substitution with the square root of, you know, I can do it with 4 minus r squared. Because the derivative of that's going to be negative 2, so I'm going to have a negative, or negative 2r, so I'm going to have a negative out in front. And, but the negative, so now I'm just doing it all in my head right now. So I have the 2r there. I need a negative 2r. So I have the 2 up, that's already up there out in front. And so I need a negative. I got the negative. And then it's to the 1/2. And so that 2 would go away, but I need that 2 and 2 there. So, and that's going to come from the derivative. So good. So all I need now is just a 4 minus r squared to the 1/2 from radical 3 to 0. All right, let's go ahead and plug in this thing because it's going to be on the last page. So I have 2 pi. Plug in radical 3. Radical 3 squared is 3. 4 minus 3 is 1. That's just going to be negative 2. Minus, plug in that, so 4 minus 0 is 0. The square root of 4 is 2. Negative 2 times 2 is 2, so plus 4. And so it looks like we're going to have just 2 times 2, which is 4 pi. All right, and that's it. So it's things that I have to add